Hello, yes.
Yes. Okay. Okay. Thank you guys for joining today's session. Taking time out of your busy schedule and joining the session. I think it's almost 150 people have joined now. I think we'll not delay much. Amit, maybe you can take over from here.
All right, thank you. Hello, everyone. Hopefully, I am audible to you, and I will start with sharing my screen. I do not know if you see my screen. Can you guys see my screen? Okay. Do you see Excalibur? All right, cool. Great. Okay, so let's start. I don't know how do I get rid of it. Cool. Okay. All right. So let's start. I will just start with introducing myself. My name is Amit. I'm based out of Bangalore and I've been in the industry for 20 years. And I have been mostly working on the DevOps, DevSecOps side of the industry, includes all the cloud tools, cloud native technologies, and what else? Yeah, all CI, CD platforms. So I've been working mostly all of my career on this. Today we are going to talk about Kubernetes, right? So I'm going to give you a brief intro of the Kubernetes. Why is it needed, right? What is it? And a little bit of how do we use it as well. So a little bit of demo, right? If time permits. Now, since it is Kubernetes, it is imperative that the participants should be aware of container technologies. Kubernetes works on top of container technologies like Docker or Containerd or any other container technology like CRIO, right? So the learners should already be aware of these things. This is not a Docker session, right? If I spend some time explaining Docker here, then we won't be able to cover Kubernetes. Okay, so that being out of the way, let's understand what is Docker, what is Kubernetes, and why do we have it. Okay. Now, before understanding Kubernetes, now we have to understand Docker. Okay, what is Docker? Well, in a compute system, right? Let me. Okay, let's say there is a server, right? It's a compute which has its own resources like hardware, resources, RAM, hard disk, CPU, network, everything, right? So let's say this is a server that we have. And on top of the servers, we can run our containers, right? So if you have Docker, you can, for example, download a Docker image or a container image. Right? You can download a container image, and from the image, you can run a container. Right? Pretty straightforward. A container is based off an image. Right? So you have an image, and from the image, you run a container. An image is like a library which contains your application and application code. A container is the executing instance of the library, right? And when you run a container, you get an application. So any client or any person or any system can access the application running on the system on the container by directly talking to it. Okay, this is what containers do. Now, why do we need containers? Why don't we run the applications directly? Because the containers are self-contained entities. That means they contain the application and their dependencies, libraries, configuration, everything within themselves. So you don't need to configure the operating system of the server, install dependencies, install configuration files and all that for the application to work. Everything is within container. Okay, right. So that's what containers are, and that's how we run containers in a system. Yeah, perfectly fine. Let's say we have a web application. Okay, I had something. Right. So let's say this is a web application that we have. And this web application is, well, it is coming from the image, but running in the container, right? And the end users are able to access the web application. Now, imagine it's a production application. So it's running in production. That means there is a real world impact if this application goes down. And let's say this container crashes for some reason, right? The container is gone for a toss. Now the clients do not get anything. They can reach out to this server, but they don't get any response. Similarly, let's say this entire server is gone. Right? This all is gone. Now client does not have anywhere to reach to. So not able to access application. Also, let's say this container is running fine, serving the application to the client, but there are like multiple clients joining, like more people want to access the application. And the count goes into millions. Now, this tiny container may try to serve all these clients by trying to use more resources from the server. So trying to use more CPU, more RAM, maybe more disk. But a time will come when this container will become, when the server will become saturated, right? That means the container cannot get any bigger. It cannot scale. And that's when it cannot entertain more clients, or it cannot entertain more requests from the same clients, and it starts misbehaving, starts dropping connections, starts timing out, or not completely loading pages and all that stuff. Okay, so that is also one more challenge with this. Now, why am I talking about all these problems? Because those are the problems that Kubernetes solves. Okay, Kubernetes enables you to run your containers in a highly scalable environment with high reliability and high availability. In this environment, there is a lack of reliability. That means we never know when the application will be down. Availability, right? So reliability means how reliable the application will work. Will it crash or will it time out or whatever? So we don't have any control on that. Same is availability. We never know when the container will go down or the whole server will go down, and then we will get problems, right? So this is a challenge here. This is a problem. There is a single point of failure, which is the server, single point of failure, which is this container. How do we solve this problem then? Okay, one thing is on a server, when you want to run container, you also need to have a container runtime installed like Docker, right? Something has to run. Only then you can run containers. Okay, now we understand the problems. What's the solution? The solution is, instead of running our application on a single server, we will run our application on a set of servers, right? So instead of running our application on a single server, we will have multiple servers with us. Okay, multiple servers. So let's say this is server 1 and this is server 2 and this is server 3. Right? 3 servers running separately. We don't need this. So how do we run the containers? Container can only run on one of the servers, right? And that's how the client will access it. What happens when we have more than one servers? How are we going to make sure that the container is running and we can access it? We know where it is running and all that shenanigans. For that, on the servers where you have the Docker installed, you will also configure something called as a container orchestrator. Okay, a container orchestrator is going to be configured on top of these servers. What is a container orchestrator? A container orchestrator is a framework which will manage the containers across multiple nodes or hosts, right? That means a container will run here, or it will run here, or it will run here. Everything with of a container lifecycle will be managed by this orchestrator. And one of the container orchestrator, which is world famous right now, is Kubernetes. Okay. There are other container orchestrators as well. For example, there is Docker Swarm. There is AWS Elastic Container Service. So these are also uh, orchestrators. ECS is actually based on Docker Swarm itself, but still. So yeah, we have this. Now, how does it work? So when we say that we use a container orchestrator, what do we essentially mean? We mean some tools are installed on all these nodes, and then there is a bigger tool or an application which manages these nodes by using those smaller tools. Okay, so when you say Kubernetes, it's not one single thing. It's not an exe that you will execute or a installer which you execute on a system and then it gets installed. That's not Kubernetes. Kubernetes consists of a lot of small components which come together to bring up this framework. Okay. Now, what are those components? First major component that we have is called, well, before I talk about components, yeah. All these nodes are going to work together to run the containers, right? So container can either run here or it can run here in this node, or it can run in this node, wherever. But how will it be decided where it will run and how long will it run? All that will be done by Kubernetes. Okay. So the first component that we have as part of Kubernetes is we need to identify one or more leaders out of these nodes. So each host, which is part of the Kubernetes cluster, is called a node. Okay, so there are multiple nodes here, S1, S2, S3. We need to identify which one is the leader. And the leader will have more responsibilities than the other nodes. Okay, so let's say S1 is the leader, also known as control plane. Right, so let's say S1 is the leader. or the control plane. Now, the control plane will have a very important component known as API server. Okay, this is a component called API server. Move it this way. And this component, what it does is it enables communication between all other components of Kubernetes. And it also enables communication from and to external clients. Okay, so if you have, I don't know if I have an icon for this. Yeah, so let's say there is a laptop somewhere, right? So this is a system external to this Kubernetes, right? And here we want to interact with the cluster to see what is running, to run more applications and things like that. So API server enables that. It enables that communication. Okay, with the external world. It receives incoming communication from the external world. And also other components, which I will talk about, will talk to each other via the API server itself. Okay, so this external client can give instructions like I am maybe a Kubernetes administrator. I can give instructions for Kubernetes to do something via API server. Okay, I can talk to it via API server. Then there is another component called a let's maybe draw them one by one. Right. So then there is a component called a scheduler. Okay. What's a scheduler? A scheduler is another component of Kubernetes whose job is to schedule containers on these nodes. So somebody is going to give an instruction to Kubernetes that, hey, run my container, and that will be received by API server. And then scheduler's job is to translate that instruction into running containers. Okay, scheduler will run the containers. Okay, all right. Now scheduler is running here. It is not running here. It is not running here. It is only on the control plane. So how does scheduler talk to other nodes? Basically, scheduler has to run a container, so it has to talk to Docker itself. How will it talk to it? So for that, we have another component known as kubelet. Okay, so there is a component called kubelet, which runs on all the nodes. And job of kubelet is to receive communication from the scheduler and execute something locally. So running containers, deleting containers, creating files locally, all those things can be done by kubelet. Also, kubelet's job is to give information back to API servers. All right, so kubelet will pass on some information to the API server. Right? So kubelet will pass information to API server. For example, how many containers are running, how much is the CPU load or disk load on these nodes and things like that. All right. Then there is another components called controller manager. Okay, controller manager. What is controller manager? I will come to that later. Okay, I will keep that as pending. And there is another component called HCD. Okay, HCD is a database. It's a very plain, simple database which stores value in key value pair. For example, it will store version is equal to something. Yeah, node 1 is equal to something, node 2 is equal to something. So it will store complete information about this entire setup within it. Okay, right. This is actually basically Kubernetes. You have one control plane where you have API server, scheduler, etcd, controller manager. Okay, maybe I should write more here. So the scheduler is going to run containers. Okay. So scheduler's job is to run containers. etcd's job is to store all the configuration. Controller manager, we will see later. Right. So this is a client. Right? Let's say a client. And this client can give instruction to the cluster and say, hey, do this. Now, instructions are of type this. Okay, pretty straightforward. The instruction could be run an application which is based on image, some Docker image or container image, like let's say Nginx. Then how many replicas of the image we want to run, let's say 2, okay, and on which port my application will be working, so port 80, right? Things like that. So we can give specifications like this. Okay, and this specification we are going to give to the API server. Now API server will receive this and will understand, all right, looks like we need to deploy an application like this. So based on Nginx container image, and I want to run an application, there should be 2 copies of application. That means 2 containers to run, and they all should run on port 80. Now, as soon as API server will get this information, it will instruct all ideal components to get these 2 containers running. And when it is done with its job, at the end, you will find 2 containers running. So imagine that these 2 containers were part of this application. I can give some instruction that run this with two containers, and I'm going to get those 2 containers running. Okay. Now you can see in the wild Kubernetes clusters with only 1 node. Those are basically test clusters. My test cluster is also a single node cluster. Okay, so you have only 1 node, and that node itself is a control plane node, and everything happens there. Or you can have 2 node or 3 node clusters. But generally you don't use such smaller clusters in production for availability reasons. Okay, so there are sometimes clusters with 500 nodes, and in the cluster there might be 6 or 7 leaders as well across the geography. Right? Cool. Okay. So now let's see an example. Okay. Before we see an example, let's come back to the client. How do you talk to the API server? So when you want to talk to the API server, right, you use a tool called kubectl. Okay. This is a tool that we use. It's called kubectl. And this tool actually knows how to interact with the API server. Now, API server is basically a REST-based API server. So you can use curl or any other REST client. But kubectl is pretty straightforward, and it has all the um, abstractions built in so that you can directly talk to the cluster. Okay. Now kubectl, to talk to the API server, it should know where it is, like which host name, which IP address, which port it is running on, and then authentication for that as well. Right? So for that, we may need to have an okay. I don't have okay. We need to have a file, and this is called kube config. Okay, this kube config is a file right. This kube config is a file which has information about the location of the API server and also how to access it, like the authentication part, if it is username, password, or some certificates, or keys, private keys, or OpenAID based authentication. Whatever is required is in kubeconfig. So this kubeconfig file is consulted by kubectl, and then kubectl talks to API server. Okay, right. So now let's quickly take a look at a demo. Before we go to the demo, are you guys with me? There's a question, should we use Docker in Kubernetes cluster? Well, that's a very valid question. I use Docker here because it's the most recognizable terminology, right, for anybody who's new to Kubernetes world. But actually, Docker is not supported as a runtime in Kubernetes since long. Okay, Docker itself does not have any Docker runtime. It also uses containerd, for example. So you can use containerd or you can use CRIO. Anything is fine. So I can fix it easily like this. If you want to use Docker, you can find ways to use it. You can hack the system, but it's going to be high maintenance and you will regularly face problems with compatibility and all. Okay, so now can you see my terminal? Okay, cool. So I have the tool kubectl already installed. I don't want to show you how to install kubectl. It's just the documentation. You can just do a Google or a chat GPT and it will tell you how to do it. And we already have the kube config created here. So if I say kubectl config view, right? So if I say, show me the kubectl config, what I have stored, well, it shows me here, right? So it says there are these clusters information that it has. There is a cluster called Docker desktop. So it is running on my local Docker and it is reachable at this IP address. And this is the certificate authority. So it has the certificate information. And then it has the users. So Docker desktop user. And this is the authentication information. So certificate and key for authenticating myself against this server. So it has all the information on how to connect to the cluster. Okay. And if you run the command kubectl, for example, get nodes, you will see that it has only one node here, which is desktop control plane, and it has a role of control plane. If there are multiple nodes, then you will find nodes which says worker or none as role. Okay. And the leaders have a role called control plane. So this this node has been up for 37 minutes. It is ready. It is with the role control plane. It is running Kubernetes version 1.34.3. And this node is called here. I can add more nodes to this cluster if I want. But right now it is just test environment. So we just have one node. All right, cool. Now, when you want to run kubectl command, it is straightforward. If you type kubectl followed by kubectl, you have to give a verb or an action like get, list, create, delete, patch, edit, right? All these are verbs, some actions that you want to perform. And then the resource that you want to perform the action on. So if you want to list all the nodes, well, you say kubectl get nodes. Or if you want to create some pods, I will talk about pods in a bit. Or you want to, do any other interaction. So that's like this. Now I'm going to run an application, right? So I showed you that we can give instruction on run an application based on this image, replica, and port, right? Let's do that. Let's run that application as a kubectl run. And with the run command, I can say help, and it's going to show me a lot of options like what can I pass, what can I do, and some examples also. Okay, I'm just going to pick up one example. Well, I just run like this. Docker run, and I'll say my application, right? And image is Nginx, replicas is 2, and port is 80. So I just give this instruction. Okay, hold on a sec. Why am I giving Docker run? What? That's crazy. I have to give kubectl. Okay, sorry, brain fog. Okay, kubectl run my application image, replicas, and the port. Okay, replica maybe. Okay. Run. I'm missing out. Oh, okay. Hold on a sec. We will come back to replicas later. We are not creating a deployment, right? Okay, let's not talk about replicas right now. Okay, so I'm running an application based on image Nginx and port 80. Click on enter, and it says this application is created. Right? That means my application is deployed. If I say kubectl get, now I have to say get pod. What is a pod? I will talk about that. And you see my application is running. Okay. Now we have to talk about two more things and then we can end the discussion. What is a pod? So I have to eat some of my words which I told you before. When Kubernetes runs an application, the scheduler runs the instances of the application across the nodes, right? So this and these Rome buses, right? These are not containers. In Kubernetes, you cannot run containers directly. You run pod. Okay. Now, what is a pod? Okay. None of the images explain it correctly. Okay, let me do it wrong. So a pod is the smallest executable on Kubernetes. Okay. In the pod, you can, well, a pod is a container which contains at least one or more containers in it. So pod is a encapsulation which can contain one or more containers in it. Okay. So this can be container 1 and then container 2 and then container 3. Right? Multiple containers in it. Containers are managed by the underlying container runtime, like container D or CRIO. These manage containers. Kubernetes does not talk to containers directly. It only creates pods. Okay. So Kubernetes says, here is a pod, run containers inside it, and the definition of container will be provided in the kubectl request or API server request. So for example, when I say kubectl run my application, it runs one pod, which has only one container, which is Nginx, and runs on port 80. So each pod gets its own IP address, okay, its own network space, network space, right? That means its own ports, set of ports, its own storage, and things like that. Okay. So a pod is like a very, very tiny VM, which gets its own network resources, and then it can run all these containers or processes in it. Most of the time, you will only run one container in a pod. Most of the time. But sometimes you will see two, rarely you will see three or more. Like if there are three containers in a pod, that means there is something that's a poorly designed application. But two is not uncommon. You can see two pods, two containers running in a pod. But one is the most common. Okay. So Kubernetes runs pods. Now, coming back here, when I say kubectl run my application, it runs a pod. So you can see pod / my application is created. Okay. So if I want, I can say kubectl describe pod, and then I can give my pod name. Describe the pod my application. And this is the complete description. Now, again, since you might be looking uh, at these details for the first time in your life, it might be overwhelming. But once you get used to it, it's pretty straightforward. So you have your application, the namespace it is running. The namespace is like project in a Kubernetes. And then how many containers is it running? So it's running one container only here. It's a YAML format. Not even YAML here, but think of it as that. So it's running my application. This is the underlying container that is running. It is based on image Nginx. It is running on port 80, and it has some storage, something mounted here, and many other details. Okay, so now my container is running, my pod is running. Let's say if I have to run an application with a scale of 2, that means 2 replicas. So that means I need to run 2 pods. Okay, and I want Kubernetes to ensure that those 2 pods will be running all the time. It's not that one pod can die and then my application is running on single pod. Kubernetes should ensure that whatever is the configuration should continue running. Okay, so for that we have a lot of controllers. One of the controller is a deployment, right? So if I say kubectl create deployment, here I'm going to say run my application with some scale and all. Okay, and let's say this is my deployment. This is the name, and image is, let's say, Nginx. Here I can specify replicas 2 and let's say port 80. So I'm saying create a deployment called my deployment, and in that 2 pods will be running, and each pod will be based on Nginx image and port 80. Right? So now it says deployment, my deployment is created. Now deployment is a controller. Okay, that means it will control the underlying pods. This will define how many pods will run, which image, which port, everything is defined by this. So if you create a controller like deployment, Kubernetes does not create the pod directly. The scheduler does not create the pods directly. As soon as you create a deployment or other controllers like daemon set, replica set, stateful sets, then there is a controller manager involved. Controller manager understands that for each control, what is the configuration defined, which image, which port, how many pods should run. And based on that, it will interact with the scheduler and provide instructions that, hey, we have got a request to run 2 pods for this application. So run 2 pods. Okay. Scheduler's job is its only job is to identify if a request has come to create a pod, it will identify which node is the best to create the pod, and it will work with kubelet to actually create the pod and containers. It cannot decide how many pods to run. It will receive requests from the controller manager directly. Okay, so yeah, that's what controller manager is. It ensures that the whatever is defined in a controller is actually implemented by talking to the scheduler. So now if I say kubectl get pods, you see my application pods are there, but there are 2 more pods running. My deployment and some weird characters. These characters make sense, but maybe some other time I will explain. And another pod. Okay. If I delete this pod, let's say kubectl delete pod. Let's say I delete my application pod. Right. This pod is deleted. And now I will see only 2 pods. And that is fine. That is expected, right? If I say kubectl delete pod, I delete pod with this F7 double XL in the name. And this pod also will be deleted, right? So if I say kubectl get pods, I still see 2 pods. And that's because as soon as one pod was deleted, the controller manager got alerted and it identified that, hey, this controller, this deployment should have 2 pods, but only one pod is running because we deleted the other one. So it will then immediately talk to scheduler and say, hey, create another pod. Okay. Right. If you run the command kubectl get pods and then -o wide, okay, it will also give you some more information about the pods. For example, on which node it is running. And wherever the pod is running, the containers also will be running in the same node. What is the IP address of this particular pod? As I said, each pod gets a unique IP address. So this is the IP address of its pod. For how long have it been running and all that stuff. Okay. So now with this approach, we can deploy our applications in a more scalable and reliable way. As I showed, if this pod is deleted or crashes, scheduler is going to create another pod, maybe in some other node or maybe somewhere else, but a new pod will be created. A replacement pod will be created. So the application will run with the defined scale. If this entire node goes down, this S2 node goes down, all the pod will start running on the remaining nodes because the controller manager will make sure that pods run. Okay. All right. Let's spend a few more minutes on the questions. That's all I wanted to share with you. There are a lot of other things that we can talk. Somebody asked me what is Istio and a lot of technologies, external tools. Unfortunately, we don't have time to discuss that. We need to have a full-fledged Kubernetes course discussion. We do not want to manually delete pods. No, it is just for demo. Sometimes you want to delete a pod if you did an exec into a pod and made some misconfiguration, then you can just delete the pod and a new one will be spun up for you. It's no, that's not correct that a pod is recreated on the same node. That's not correct. It all depends on the load on your nodes. So the scheduler will always decide based on affinities, based on labels, based on taints, and the actual memory and CPU pressure on the nodes, where to run the pods. Okay, it's not that on the same pod it will run. In my experience, it generally runs on an other available node if a pod is killed. Yep, config maps, secrets, all these are Kubernetes terminologies which we can talk about when we have more time. How many maximum containers? There is no limit on maximum containers, but if you have to run more than 2 containers in one pod, you are doing something wrong. Okay, what else? Any other questions? Do you have any questions? Possibly that stale application code lies in a pod. So whenever you update your application, you need to publish a new container image with a new tag. And then you need to update your deployment with that tag. And as soon as you do that, Kubernetes will start rolling out a green-blue update. And if the new update, if the new pods don't come up, then the old pods continue to run. Okay. So unless your new application is not coming up, I don't see any chances of stale application being in the pods. There's a question, why running more containers in same pod is bad architecture design? Because you are tied up to that set of containers. And if you scale your deployment, let's say if this pod has 5 containers, and then you scale your deployment to, let's say, 10, then you will start running 10 pods. All of those 10 pods will have those 5 containers. So unless you really want that, you do not want your pods to have more containers. How to scale a deployment using kubectl? Yeah, straightforward. Kubectl scale and deployment, and then I can give my deployment, right? Replicas equal to 5. So now I am scaling my deployment, and now replicas will be 5. And you can see 5 replicas are here. If I'm getting the HTTP protocol error for the application running on Kubernetes related to deployment or controller manager or kubelet, it can be anywhere. Okay, it could be at the service level or at the ingress level or at the pod level or at the application level. You really need to debug this entire flow. How the application is exposed to external world, that is using services and ingress, which we can talk about some other time. Is the leader node get updated, changed to some other node? No, but you always should have more than one leader, right? One leader is again a single point of failure. So if this leader goes down, your entire cluster is going for a toss. So you should have more than one leader. And in the leaders also, you should have redundancy. So, one leader in one region, another leader in another region, or maybe separated by availability zones for reliability. How do we rectify pod crash loop back off? It depends on why it is crashing. Right? Is the image not running or image not available on the registry, or is the default command or entry point not defined correctly? There could be many, many reasons. Any best practices or tool? It is your experience. But if you use Claude or any other tool, there are a lot of MCP servers available. So you can just plug those MCP server to your Claude or Windsurf or any other AI tool. Well, coding agent tools, and they can help you with that. They are pretty good at that now. All right, guys, that's all the time that I have got. I have go to my next meeting. So thank you for your time. If you want to try this, practice this online, create an AWS free account for 1 year. You can create Kubernetes clusters for like almost free and then use it. Okay. Thank you, folks. Interesting questions, and I hope I could add something to your knowledge and help you, with your learnings. Thank you so much. Please, share any feedback with the team. Thank you, and also please let us know what do you want to learn in the next sessions. Thank you, guys. Have a good day. Bye.
Thanks, Amit. Thanks, Amit, for the wonderful session. Thanks, guys. Have a nice day. Bye-bye.